To write the balanced net ionic equation for calcium nitrate plus potassium carbonate, first we need to balance the molecular equation. This is the molecular equation. So if we put a 2 in front of the KNO3, the potassium nitrate, that balances the molecular equation. Next, we need to write the state for each substance. That'll look like this. So if you know your solubility rules, compounds with the nitrate ion, this NO3, are very soluble. So they're aqueous, they break apart into their ions. In general, carbonates are insoluble with a few exceptions. Some of the group 1 elements like potassium and sodium, they're soluble, and ammonium carbonate, that's soluble. But in general, they're insoluble. So our potassium carbonate, potassium's in group 1, that's soluble, but calcium carbonate is insoluble. That means it's a solid. These two substances react, we get a solid, it's a precipitate. It'll fall to the bottom of the test tube or the beaker. So we have our states. Next, we split the strong electrolytes into their ions for the complete ionic equation. That looks like this. So this is the balanced complete ionic equation. Now we can cross out spectator ions. They're on both sides of the complete ionic equation. So on top are the reactants and on the bottom are the products. And I can see right away in the reactants there are 2 nitrate ions and in the products. So these are spectator ions. We cross those out. 2 potassium ions in the reactants and in the products here. So cross those out. Spectator ions. What's left though, that's the net ionic equation for calcium nitrate plus potassium carbonate. Let's remove these spectator ions here. And this is the balanced net ionic equation for the CaNO3 plus K2CO3. You'll note that the atoms, they're balanced, same on both sides, and the charge is the same, 2 plus and 2 minus. That gives us a net charge of 0. This is neutral, net charge of 0. This is Dr. B, and thanks for watching.